Alright everyone, how you guys doing today? We're moving on to the next one, classes and objects. I think we're gonna, actually not sure what this chapter is about exactly. We'll get into it. Because I feel like the important stuff regarding classes they covered in the previous one. At this point we have defined classes and created objects that represent the time of day and the day of the year. And we've defined methods that create, modify, and perform computations with these objects. In this chapter, we'll continue our tour of object-oriented programming by defining classes that represent geometric objects, including points, lines, rectangles, and circles. We will write methods that create and modify these objects, and we'll use the Jupytertal module to draw them. I'll use these classes to demonstrate OOP topics, including object identity and equivalence, shallow and deep copying, and polymorphism. Yeah, so, okay, I get it now. Creating a point. In computer graphics, a location on the screen is often represented using a pair of coordinates in an XY plane. By convention, the point 0, 0 usually refers to the upper left corner of the screen, and XY represents the point X units to the right and Y units down from the origin. Compared to the Cartesian coordinate system you might have seen in math class, the Y-axis is upside down. There are several ways we might represent a point in Python. We can store the coordinates separately in two variables, X and Y. We can store the coordinates as elements in a list or tuple, and we can create a new type to represent points as objects. In object-oriented programming, it would be most idiomatic to create a new type. To do that, we'll start with a class definition for point, right? So this is some point in space, self.x, self.y, and string return point blah. The init method takes the coordinates as parameters and assigns them to attributes x and y. The str method returns a string representation of the point. Start equals point 0, 0, print start point 0, 0. Following diagram should show the state of the new object, which is very simple. As usual, a programmer-defined type is represented by a box with the name of the type outside and the attributes inside. In general, programmer-defined types are mutable, so we can write a method like translate that takes two numbers, dx and dy, and adds them to the attributes x and y. Def translate. So it just adds whatever the new amount is to x and y. This function translates the point from one location in the plane to another. If we don't want to modify an existing point, we can use copy to copy the original object and then modify the copy. End equals copy start, n1.translate 300, print end. We can encapsulate those steps in another method called translated. And this method, in the same way that the built-in function sort dot translate return point. In the same way that the built-in function sort modifies a list and the sorted function creates a new list, now we have a translate method that modifies point and translate a method that creates a new one. Here's an example. In the same way the built-in function sort modifies a list and the sort function creates a new list, now we have a translate method that modifies a point and translated method that creates a new one. Creating a line. Now let's define a class that represents the line segment between 2 points. As usual, we'll start with an init method and a str method. Boom, boom. So this is just a line. With these two methods, we can instantiate and display a line object we'll use to represent the x-axis, right? So it just takes 2 points, which we just defined, right? Because you can utilize other classes within other classes, obviously, or instances of other classes, obviously. When call print and pass line as a parameter, print invokes str on line. The str method uses an string to create a string representation of the line. The string contains 2 expressions in curly braces, self.p1 and self.p2. When those expressions are evaluated, the results are point objects. Then when they are converted to strings, the str method from point class gets invoked. That's why when we display a line, the result contains the string representation of the point objects. The following object diagram shows the state of this line object. So yeah, this is basically just talking about like, hey, we just printed this object here, right? Why am I getting line 0.00, Isn't that from the point object? And then we have to call it as stir self.p1. Well, no, because the dunder method, anytime a string casting needs to be done, whether it's implicitly or explicitly, it will call the dunder method. So this is implicitly getting cast to a string because you're putting it as part of an f strings, and like that needs to be printed out, right? So you don't actually need to do it separately. So this is the state diagram, right? Where line 1 points to an instance of a class line with start and end attributes, which are both pointing to, which are both references to a point object, a different point object. String representations and object diagrams are useful for debugging, but the point of this example is to generate graphics, not text. So we'll use Jupyter Turtle module to draw lines on the screen. As we did in chapter 4, we'll use MakeTurtle to create a turtle object and a small canvas where it can draw. To draw lines, we'll use two new functions, Jupyter from the Jupyter module. Jump2, which makes takes two coordinates and move the turtle to give the given location without drawing a line, and Move2, which moves the turtle from its current location to the given location and draws a line segment between them. Okay, add method draw Jump2 and Move2, and you can give it the points. To show how it's used, I'll create a second line that represents the y-axis. Line 2 equals line start end 2, boom boom, and then draw the axis, boom boom boom. Pretty straightforward. Line 1 dot draw, line 2 dot draw, which is the method that we just created here, Jump2 and Move2. As we define and draw more objects, we'll use these lines, but first let's talk about object equivalence and identity. Suppose we create 2 points with the same coordinates, p1 and p2. If you use the equals equals operator to compare them and get the default behavior of the program, the result is true, only if they are the same object, which they are not. False. If we want to change that behavior, we can provide a special method called EQ that defines what it means for 2 point objects to be equal. There you go. Right? This definition considers 2 points to be equal if their attributes are equal. Now, when we use the equals equals operator, it invokes the EQ method, which indicates that P1 and P2 are considered equal. But the is operator still indicates that they are different objects. Yeah, so that's actually what I was going to get to, is that they are different objects. They're just equivalent, right? It's not possible to override the is operator. It always checks whether the objects are identical, but for programmer-defined types, you can override the equals equals operator, so it checks whether the objects are equivalent, and you can define what equivalent means. Creating a rectangle. Now let's define a class that represents and draws rectangles. To keep things simple, we'll assume that the rectangles are either vertical or horizontal, not at an angle. What attributes do you think we should use to specify the location and size of a rectangle? At least 2 possibilities. You can specify the width and height of the rectangle and the location of one corner, and you can specify 2 opposing corners. At this point, it's hard to say whether either is better than the other, so let's implement the first one. Here's the class definition. Self.width height corner, return rectangle, self.height width corner. Rectangle 150.3020. Corner, okay. The following diagram shows the state object. To draw a rectangle, we'll use the following method to make 4 point objects to represent the corners. Boom, boom. So this is just, I'm not going through these codes that deeply, unless it's something that I personally find interesting, because most of it is arbitrary code. But good stuff to go over and understand if you're a beginner, but for me, I just really want to rush through and talk about this all conceptually. We'll make 4 line objects to represent the sides, add method to rectangle, make lines. Then we'll draw the sides, add method to rectangle, draw, make turtle, line 1 dot draw, line 2 dot draw, box 1 dot draw. Here's an example. Um, Changing rectangles. Now let's consider two methods that modify rectangles: grow and translate. We'll see that grow works as expected, but translate has a subtle bug. See if you can figure it out before I explain. Grow takes two numbers, d width and d height, and adds them to width and height attributes of the rectangle. So that demonstrates the effect by making a copy of box 1, invoking grow on the copy. Draw box 1, we confirm the grow works as expected. Boom, 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 boom. Now, let's see about translate. It takes two numbers, dx and dy, and moves the rectangle the given distances in x and y directions. Add method to rectangles. Def translate. Box 2 dot translate rectangle 16090.6040. Now let's see what nikalo. Now let's see what happens if we draw box 1 and box 2 again. Make turtle line 1 dot draw, line 2 dot draw, box 1 dot draw, box 2 dot draw. I'm just gonna pause this. All right, continuing on. Box 2 dot translate. So let's see what happens. Yeah, I'm not even gonna go through the code on this. I don't really care that much. But essentially, what we're just talking about is like, using classes in other classes, right? Which is an important aspect of all of this. And I'm sure soon they're going to talk about inheritance as well, where you can use inherit like one class and then change, like be like, hey, I want all of these functions from this class, and then I'm going to add more functions to create another class. So for example, rectangle could actually inherit from a higher level class called shape, right? And then you could have a bunch of different classes that inherit from shape, which provides some useful functions, which then are extended upon by others. So I think they're about to get into that. Deep copy, when we use copy to duplicate box 1, it copies the rectangle object, but not the point object it contains. So box 1 and box 2 are different objects as intended. But their corner attribute refers to the same object, right? Because the point isn't copied. Following diagram shows the state of these objects. So yeah, basically both of these point to the same corner, even though they're different objects. What copy does is called a shallow copy, because it copies the object but not the objects it contains. As a result, changing the width or height of one rectangle does not affect the other. All right, coming back. So yeah, this is the thing that I had referenced many chapters ago. Essentially, when you copy an object, right, whether by just going list, whatever, some list or whatever, like however you copy, because there's multiple ways that copies are created. Any thing that is nested that is an immutable object, is a mutable object, will usually reference the same thing still. And so if you want it to actually deeply recreate everything, even if it's a mutable object, you need to use deep copy. So that's the whole thing here. And we'll make a deep copy. Box 3 corner is box 4 corner, no, right? And that's really important to understand this concept. And my wife just got into the video for a moment as she was grabbing my microfiber cloth to clean her glasses, and she is looking lovely as ever. She's wearing these new earrings that are like different shapes. There's like a little triangle and a star and a circle. And
Focus on your video.
Huh?
Focus on your video.
Well, okay, people who are watching this should know that I love my wife and that having a loving relationship matters. So I think, because I mean, I don't see, hey, I don't see, I mean, this channel isn't me teaching things. It's at best teaching you how to teach. And, having good relationships is important. It's how, there's a lot of things that go into learning yourself, right? Learning how to learn isn't just about the meta skills of learning how to learn, but also actually being in a good place to, because if you're not in a good place, you're not even going to trust yourself or believe yourself to actually be able to learn effectively, right? And one of the things that helps that happen is being in a true and happy relationship.
Yeah, that's true.
Okay, so that aside, I'm getting back to polymorphism.
Polymorphism is also a bio concept or something?
What?
Polymorphism?
Yeah, I think in bio it's basically things that can change shape, like animals and stuff. I could be wrong. I don't remember. I don't know if is polymorphism defined in biology. It feels like it, but I'm not sure. Existence of two or more distinct forms or forms within a single population of the same species. Yeah, there it is. That's what I recall. So like, yeah, alternate phenotypes at various levels, including anyways, genetic polymorphism. Yeah, that's anyways. We're getting back to actually polymorphism. In the previous example, we invoked the draw method on two line objects and two rectangle objects. So we can do the same thing more concisely by making a list of objects for shape and shapes, shape.draw. The first and second time through the loop, shape refers to a line object, so when draw is invoked, the method that runs it is the one defined in the line class. The third and fourth time through the loop, shape refers to a rectangle object, so when the draw is invoked, the method that runs is the one defined in the rectangle. Since each object knows how to draw itself, this feature is called polymorphism. The word comes from Greek roots that means many-shaped. An object-oriented polymorphism is the ability of different types to provide the same method, which makes it possible to perform many computations like drawing shapes by invoking the same method on different types of objects. As an exercise at the end of the chapter, you'll define a new class that represents a circle and provide a draw method. Then you can use polymorphism to draw lines, rectangles, and circles. Is that really what polymorphism means? I thought it was more related to like inheritance and stuff. I use variables of different types at different times. In computer science, polymorphism from the Greek many forms refers to the ability of a single interface function or variable to take on different forms or exhibit different behaviors depending on the context or the specific type of object it interacts with. Yeah. So, okay, conceptually, I guess what he's saying, like what he's described here is polymorphism, because the interface of all of these methods is the same, even though the implementation differs, right? And the formalization of that is when you start inheriting classes, right? So for example, the draw function is there everywhere. So if possible, make either a really generic version of draw that all subsequent functions need to use, all subsequent inherited classes need to use, which then you reuse the same draw function and then add some extra stuff on it. Or you can create a high-level interface class which has zero implementation, and then you inherit from that class and overload those functions to provide your specific functionality, right? And both of these are extremely important. Like, that's why polymorphism and inheritance are very interrelated. Yeah. Anyways. The word comes from Greek roots that mean many-shaped and object, blah, blah, blah. Okay, we already went through this. Debugging. We're almost at the end of this chapter. Good, because I only have 5 or 10 minutes before I gotta go for a meeting. In this chapter, we ran into a subtle bug that happened because we created a point that was shaped by two rectangle objects and then we modified the point. In general, there are two ways to avoid problems like this. You can avoid sharing objects, or you can avoid modifying them. To avoid sharing objects, you can use deep copy as we did in this chapter. To avoid modifying objects, consider replacing impure functions like translate with pure functions like translated. For example, here's a version of translated that creates a new point and never modifies its attributes. Python provides a feature that makes it easier to avoid modifying objects. They are beyond the scope of this book, but if you are curious, how do I make a Python object immutable? I'm actually curious about this. I'm just gonna do that. Command C TV and remove that stunning double quote. What is he talking about? Using data classes with frozen equals true. Yeah, that sounds about right. Yeah, I forgot about that. I feel like, why use data class versus Pydantic? This is like a small thing that probably is a bit too advanced for people who are watching. And the third part depends on specific requirements, particularly concerning data validation and handling. When simplicity and internal data structure, performance is critical. reduced boilerplate, no external dependencies. Robust data validation, working with external data sources or APIs, serialization and deserialization, automatic type coercion, integration with frameworks, generating JSON schemas. Yeah, okay. This is fair. Basically, it's kind of like the shelf example where it's like, okay, if you have a use case that is simple and works with the provided functionality, use that. Otherwise, go to Pydantic, right? I don't really have much of an option. If you're following along from the previous series, Fast API kind of enforces the utilization of Pydantic, which is actually a good thing in my opinion. Anyways, is this a how do I make a Python object? Yeah, so and I'm pretty sure you can set frozen on like Pydantic objects as well. Creating a new object takes more time and than modifying an existing one, but the difference seldom matters in practice. Programs that avoid shared objects and impure functions are often easier to develop, test, and bug, and the best kind of debugging is the kind you don't have to do. Yeah, I agree with the statement, but I think in general it's good to be aware of both of your options and seeing which is more useful in which situation. Exercises. Ask a virtual assistant. If you For all the following actions, if you do, you'll want to include as part of the prompt the class definition of point, line, and rectangle. Otherwise, the VA will make a guess about their attributes and functions, and the code it generates won't work. Run EQ method for the line class that returns true if line objects refer to point objects that are equivalent in either order. Okay, totally works. Some classy stuff. Write a line method called midpoint that computes the midpoint of a line segment. Yep. Write a rectangle. Write a rectangle method called make cross that uses make lines. Okay. It's all pretty straightforward stuff. So let's not worry about that. We're just gonna end the chapter here right now. Let's quickly check. So we only have 17 inheritance. That's the next episode chapter. So we basically have 2 more videos left, 3 more chapters. I'll do inheritance in the next video, and then Python extras and final thoughts, and then right after that I'll get back to the original series we were working on. Thank you all so much. Take care. Have a great one. Bye bye.